So here we are, a question to our second uh, skills question. And it's a question that a lot of you may have started with. It's a question here which you can see has to do with a area under a curve. So you'll have identified as an integration question. The graph of the curve with equation y equals 16 over x squared minus x over 2 plus 1 is shown below, and x is greater than 0. The finite region R bounded by the lines x equals 1, the x-axis, and the curve is shown. The curve crosses the x-axis at the point 4, 0. So here we go. This is x equals 1 and x equals 4. We know those are going to be important. Copy and complete the table of y values corresponding to x equals 2 and x equals 2.5. So I think this was a nice little introduction to this question because we have our function up here. Y is equal to 16 over x squared minus x over 2 plus 1. And we have our table down at the bottom. And what we have to do is we've got to put in 2 for x. And when we do, we get 4. And we put in 2.5 for x. And we end up at 2.31. And Andrew, I think that was a 5-mark question.
Yeah, absolutely. So it's marked on a 0-3-5 scale. So partial credit here for 3 marks was for getting the 4 right, or getting the 2.3 right, or correct working for either of them. So if you subbed in the 2 or you subbed in the 2.5, but you didn't end up with correct answers at the end, you can get the partial credit here for 3 marks.
Okay, so that's, that was a kind of nice introduction to it. But these y values are going to be important for us here in one moment, because we're going to be asked in part B to use the trapezoidal rule with all the values in the completed table to find the approximate values for the area R. So we're going to find the approximate value for this area, giving your answer to correct at 2 decimal places. Now, when it says trapezoidal rule, you're thinking to yourself, you got to go to the table book. On page 12, you're going to find the formula for the trapezoidal rule, and you're going to say the area is h over 2 times y1 plus yn plus 2 times y2 plus y3 plus y4 all the way to plus yn minus 1. Now, what throws off students sometimes is h has to do with width. So it's the width of the interval. In our case, it's going to be 0.5. And y then has to do with the heights. So y1 is your first height, yn is your last height, and y2, for instance, is your second height. You can see in the formula what you're doing is you're adding together the sum of all the remaining heights and multiplying it by 2, because you've already put in your first height y1 and your last height yn. Okay, so here's what we do. We fill in our formula. The height, the h, I'm falling into the same trap myself. The width is 0.5. It's 0.5 over 2 times 1 times 16.5, which is your y1. Your last height is 0 because it's over here at the 0.40, and it's 2 times the sum of the remaining heights. I multiply it out, I get an approximate answer as 11.8775. And of course, I want to correct it 2 decimal places, so it's approximately 11.88 units squared. It's a 5-mark question.
So this one's marked on a 0-3-5 scale. So partial credit here is for any correct substitution into the formula. So even if you only substitute in one thing correctly, you can have partial credit here for 3 marks. It is a starred question, so that means that incorrect rounding and or units is 4 marks. So if both of those are wrong, so you round incorrectly and you let off the units, it's still 4 marks. You only get penalised once. You only drop 1 mark for those 2 things.
Okay. So now we've used the trapezoidal rule to find the approximate area, but now we're going to use integration to find the exact area. And as we know, that's one of the uses of integration, to find the area of an irregular shape. It's going to be a definite integral question because we have our limits of 4 and 1. Okay, so that's my upper value is 4, my lower value is 1. I'm going to be integrating 16 over x squared. We know 16 over x squared is the same thing as 16x to the power minus 1 minus x over 2 plus 1. I integrate that to get minus 16 times x to the power minus 1 Sorry, I made a little mistake here. Let me go back here. I had 16 over x squared is equal to 16 to the power of 16 times x to the power of minus 2. I was rushing ahead of myself there. When I do my integration, I'm going to add 1 to that negative 2. So that's going to become negative 1. I'm going to divide by that new power, and that's how I end up at negative 16 times x to the power of minus 1. My x over 2, I'm going to add 1 to the power there, so I'm going to get x squared, I'm going to divide by 2, so I'm going to end up at minus x squared over 4, and my 1 is going to integrate to be x. So my limits then are going to be 4 and 1. When I put in my 4, I'm going to get the value in this bracket. I know some of you will work that out at this stage. That's absolutely fine. And we're going to get the value in this other bracket when I have my lower limit of x equals 1. I'm going to subtract 1 from the other, and I'm going to get an exact answer of 11.25 units squared. And that is a 10-mark question.
So this one's marked on a 0, 5, 8, 10 scale. So low partial credit here for 5 marks is some correct integration, so any correct integration step, or a correct substitution into an incorrect integral. So you integrated incorrectly, but you correctly substituted in 4 or 1. That would come for low partial credit here in 5 marks. High partial credit is a fully correct integral or correct substitution into an incorrect integral that had some correct integration. So you got some of the integration right, but not all of it, and you correctly put in the 4 and 1. That would be high partial credit here for 8 marks. Units it makes this a start question. So if you have no units, 9 marks are available with the correct answer.
Okay, we're on to our last part of this one. Find the percentage error between the approximate and the exact values found. So we know the approximate value was 11.88 and our exact value was 11.25. The difference between them is your error, that's 0.63. Your percentage error is your error over your exact by 100 over 1, and that turns out to be 5.6%, and that was a 5-mark question.
So this one's on a 0, 3, 5 scale. Partial credit here is some correct substitution. So if you put in some parts of that right into a formula to find the percentage error, you can get partial credit here for 3 marks. The percentage sign is not needed for the full credit. Okay, so you do not need the percentage sign here to get the full credit. So 5.6 will get you the full credit here.
Okay, so that brings us to the end of this question, and we found that students kind of felt I think did relatively well in this one. Okay, so that brings us on to question